Good afternoon. We are continuing our adventures with solving. Lesson 6 was all about solving exponential equations, and now in Lesson 7, we're going to be solving logarithmic equations. So our concept is logarithmic equations. So a logarithmic equation is an equation that contains a variable in the log or natural log that you are trying to solve for. So our first concept is to solve logarithmic equations using a common base. So if two logarithms of the same base are equal, then their contents are equal. Just like with exponents, if their bases are equal, then their exponents are equal. Now, just like with exponential equations, you may have to use some properties of logarithms to simplify the equation first before you solve. So, solve each equation for the variable. So our first one is log base 15 of x plus 8 is equal to log base 15 of 4x minus 7. Now, as you can see, on both sides of the equal sign, we have log base 15. So they are the same, therefore the contents are equal. So we can drop the log base 15 and just have x plus 8 is equal to 4x minus 7. Now all we have to do is solve for x. I'm going to subtract an x from both sides. So we have 8 is equal to 3x minus 7. Add 7 to both sides. 15 is equal to 3x. Divide by 3. And we get x is equal to 5. All right, our next one. We have log 4 plus log of negative 3b is equal to log 24. So, as you can see, we have logs being added. So we need to condense them first using multiplication. So we're going to multiply 4 and negative 3b. So we'll have log of negative 12b is equal to log 24. Logs are equal on both sides, therefore the contents are equal. So we're going to drop the logs. Negative 12b is equal to 24. Divide by negative 12. And we get b is equal to negative 2. So the big thing when you have common logs is it needs to be condensed all the way down to a single log first before setting the contents equal. All right, now we're going to look at logarithmic equations that do not have logs on both sides. So, the concept, oops, I did not. This should be rewrite log equations as exponents. Sorry about that typo. That one I did not catch. But yes, if we are trying to solve an equation with log or natural log in it, first we need to do any condensing, then convert it into an exponential equation to solve for the variable. So first, let's recall how we convert. So converting from a log to an exponent. We have log base b of y is equal to x. And to write it as an exponent, we're going to have base b to the power of x is equal to y. All right, natural logs. If we have the natural log of y is equal to x, to write it as an exponent, remember natural log is base e to the power of x is equal to y. So these first two examples, the first thing we do, convert to exponent form, and then we're going to solve. So here we have log base 3 of x is equal to 2. Convert it to an exponent. So base 3 to the power of 2 is equal to x. And then 3 squared is 9. So x is equal to 9. Now, you are going to have to do just a teensy bit more solving. So this next one, log base 11 of negative 4x plus 9 is equal to 2. Convert to an exponent. Base 11 to the power of 2 is equal to negative 4x plus 9. All right, now simplify and solve for x. 11 squared is 121 is equal to negative 4x plus 9. Solve for x. Subtract 9. And 121 divided by 9. Nope, not divided. 121 minus 9 is 112. It's equal to negative 4x. Divide by negative 4. And we get x is equal to negative 28. All right. On the next page and in the next video, we're going to look at some more involved problems where we have to move stuff before converting to an exponent. So I'll see you here very shortly.